Hey everyone, I'm Hadia Samreen. I'm assistant professor from the Department of Computer Science, St. Joseph Degree and PG College. So in our lecture series, we will be today dealing with transactions and its properties or properties of transactions for the course titled Relational Database Management System, that is RDBMS. So let's get started. First, we will briefly introduce what is transaction. Transaction is collection of operations that form a single logical unit of work. Like we can do multiple operations using in a transaction. It can include insertion, deletion, modification, retrieval, commit, rollback, operations, etc. etc. Committing means to save our data permanently in the database, and rollback means whatever work we have done, we can undo the work. So these are some operations. So transactions can be accessed, you can access database using how many operations? These two operations like read and write. Okay. So there are some properties. Asset property, we call it as asset properties for transactions. So the A stands for atomicity, C consistency, I isolation, D durability. These properties are used so as to ensure integrity of the database whenever we access it or update it by any transaction. So for the maintenance of its integrity, we make sure that all these properties are satisfied. So first one is atomicity, right? What does it mean? It refers to the ability of a DBMS to guarantee that either all of the tasks of transaction are performed or none of them. Means it is what all, it is known as all or nothing. Let's see an example to understand it better. Atomicity. So let's suppose, let me take a pen. So yeah, let's suppose we have two accounts. This is vanishing. Yeah. So let's suppose we have two accounts. First one is A and second is B. And let's consider A and B are containing how much amount in the beginning? 1000. 1000 A and 1000 in B. So we will now start a transaction. So we are trying to start a transaction. The transaction is T1. We are trying to deposit rupees 100 from A to B. From A to B, we want to deposit 100 rupees. Transfer 100 from A to B. A has 1000, B has 1000. We want to deduct 100 and add 100 over here. So how do we do that? First, we will read A. When we read A, it will return 1000. Then we will deduct A equals to A minus 100. A minus 100, A minus 100 means A is containing 1000 minus 100 means 900. So we are left with 900 for A. Now we will write A. Write A. We are writing that we are changing the amount in the bank account, in this account A, that is from 100 to 900, from 1000 to 900, that is 100 is deducted. 100 has been deducted. Now we will go and read B. B has 1000 rupees. Now we will try to add B 100 in B. 100 has been deducted here, we need to add 100 over here. But let's consider that when we are trying to deduct 100 from A, it has been deducted, correct. But when we are trying to add 100 to B, it is not getting added over here. Alright, so atomicity is not maintained. It is not consistent. The amount has been deducted from here, but it has not been added over here. So this is not consistent. So atomicity property is not satisfied over here. So, so as to preserve our database, what do? We will roll back. As we have seen, it is all or nothing. This one wrote the data correctly. This one did not write the data. Right. 100 did not get added over here. 100 has been deducted from here but did not get added over here. So, since all is not correct, then we will just roll it back. Roll back means we will cancel all the transactions, means we will roll back the whole transaction so that we can preserve the database and it will go back to its original value. That is 100,000 in B and 1000 in A. So it has been rolled back. That is known as atomicity. Then comes consistency. Consistency means the amount. Let's again consider we have two accounts A and B. So A plus B before transaction and A plus B after transaction must be same. The value, the sum of A and B before and after must be same, must be consistent. That is the property of consistency. So let's again suppose two accounts A and B, each containing how much amount? 1000. So now we will start a transaction. We are again trying to deduct 100 rupees from A to B. So how do we do that? Read A minus 100, write A, read A 1000, A minus 100, 1000 minus 100. So before transaction, the original values are original value for A is 1000, original rupees, original amount of B is 1000. 1000 plus 1000 is 2000. Okay. Now, after the transaction, when we are deducting the 100, then writing 900, it's written over here. Then we are trying to add 100 over here. So it becomes 1100. So this was before transaction, this is after transaction. Now after transaction, when we try to add A value is 900, B value is 1100. 900 plus 1100 is 2000. So is the value same before and after the transaction? Yes. So that means it is consistent. If at all if these two values are different, then it is not consistent. That means it does not satisfy the property of consistency. Hope you understood. Next one is isolation. Isolation simply means that, for example, let's suppose there are more than one transaction. Till now, we have only seen we were only dealing with one transaction at a time. But let's suppose simultaneously more than one transactions are being processed. For example, T1 and T2 on the same accounts, A and B. Then there will be clash, there will be some difficulties, right? So, isolation suggests that unless and until the complete transaction isn't complete, the transaction isn't complete till the end, it should not commit. It should not commit. It should only commit when it ends. See, for example, T1 has been executed till read of P only, and it is not executed here. So we will only be getting A plus 100. That is, see, we have two accounts A, B, right? Each containing 1,000. We will read A, it has 1,000. Then we will add 100, that is 1,100. Now A has 1,100. Now we went on to read B for the next line. But we did not execute these two lines, B minus 50 and write of B. We just read B and stopped till here only. That means the transaction has not been completed. So what will be the sum? A plus B will be 2100. Since A became 1100 and B was already 1000. So total will be 2100. But it is not consistent, right? So that means this will result in inconsistency because the changes should only be visible when they have made to main memory. When this all transaction ends, when it commits, then only it will go to main memory and changes must only be visible then. Otherwise, it will be a big problem for us. So that is known as isolation. That is, the changes must be only visible after they have been made to the main memory. Last one is the durability. This property ensures that once the transaction has completed execution, the updates are stored in and returned to disk. Means even if the system fails, even if system failure occurs, the transaction that has been completed, the updates must be stored already. Even after system fails, the stored update must be permanent. It must be stored permanently um, in non-volatile memory because it will never be lost. So that is known as durability. Durability means anything will happen. Anything can happen. System failure can occur. Even after that is occurring, we must make sure that our um, update our updates and modifications are never lost. That is known as durability. So these four were the in short, all in all, we had how many properties? Four properties, that is atomicity, consistency, isolation, and durability. Atomicity means all or nothing. Consistency means the database must be in consistent state. like before sum must be equal to after sum. Isolation means that um, the changes must be made after it is done to the main memory, and during the execution of a transaction can't be used by another transaction until and unless the first one is completed. And durability means if the transaction is successfully completed, the updates and modifications must be permanent or persistent. That means it should not be undone, it should never be lost. These four were the properties. Thank you. Hope it helped. Thank you for